Right, the next part of section 1 in chapter 13 is simplifying trig functions, and really we're talking about simplifying expressions. Now when we simplify, we are trying to get it down to either a single trig function or a number. So that's the ideal situation. Sometimes that just won't be possible, but most of the time that's what we are looking for. So we're going to be using the reciprocal, the quotient, and the Pythagorean identities to rewrite and simplify. Let me add that to the notes. To rewrite, then simplify. Now, typically we consider sine and cosine to be the most basic of our trig functions because all the other functions are derived from those two things. So if you get stuck, try writing things in terms of sine and cosine, and then keep going. Now it's very important that you guys understand that there is more than one correct way to work through these problems. I'm going to try and show you the most concise steps to do it, but that doesn't mean that it's the only correct way to do that. So if you have 2 or 3 extra steps compared to what I show you, that's completely fine. And that's to be expected until you get a lot of practice at these. So the most frustrating thing that I see from students is that they just don't know how to start, or they don't know how to keep going at a certain point. And the best thing to do is just try something. And when I say try something, I mean you're going to look at something, you're going to decide what to replace it with, and hope that it works out. Sometimes it will, and that's great. Sometimes you might all of a sudden be 4 or 5 steps in and you have a way more complicated expression than when you started, and that's okay too. At that point you're going to say, no, this isn't going where I want it to go, and you're just going to stop, you're going to start over, and you're going to try a different first step. So these can be very frustrating problems to work through in the beginning. It is going to take practice and just accepting the fact that you're not going to be perfect at it every time. Okay, I've been doing this for 10 years. I still make mistakes where I get into the problem and it's way too complicated and I have to start over. Okay, so that is to be expected. So just accept that that is going to happen and that you are going to be a little frustrated at times with these, but you just have to keep finding ways to work through it. Okay. All right, so again, we are going to be focusing on our reciprocal, the quotient, and the Pythagorean identities. Okay. So most of the time we're going to be up here doing this. So when you are looking at things, we are probably looking to replace things with their reciprocal, or if we're seeing tangent or cotangent, we're going to want to be replacing them with the quotient identities. So the only time we should be working with these is if we have the squareds somewhere in our steps. Okay, and remember too that for sine squared, that's equal to 1 over the cosecant squared. So we just assume that these powers would be the same when we're rewriting. So I'm just going to start working through a bunch of practice. We're going to start off easy and then move to some more complicated ones. All right, so simplifying each expression as much as possible. So again, our goal is to get it down to a single term or a number. And to start with, when we replace, usually we replace things other than sine and cosine. So I'm going to start with this secant and replace it with its reciprocal function. So this is going to be equal to sine theta times 1 over cosine theta. And since we're multiplying straight across. So this will become sine theta over cosine theta. And then I should be able to recognize that as the quotient identity. So to get tangent. And then I have a single term. I don't want to go any more. So this is going to be my final answer. Okay. So I would recommend pausing this video right now and practicing what you can see on your own, and then you can look at my answers. Okay. So next one, I am going to start by replacing cotangent with its quotient. So this is going to be cosine theta over sine theta. So again, notice how we're writing things in terms of sine and cosine. And as I replace this cotangent, I'm also going to replace the secant with its reciprocal. So this will be times 1 over cosine theta. Okay. And then that means that I can cross-reduce my cosines, since it's multiplication. So I'm going to have 1 over sine theta. And for something to be considered simplified, we don't want a fraction, so then I'm going to rewrite this using the reciprocal function of cosecant theta. So this will be my final answer. Okay. All right, so 8, again, I'm going to not replace the sign, I'm going to go to this one, and I'm going to replace it with its reciprocal. So this will be 1 over sine theta, and then still times sine theta. So I'm allowed to cross-reduce, which means I am left with 1. So sometimes for these problems, we are just going to get a number for our simplified answer. So that's completely fine if that happens. And it could be a negative number too. All right, let's keep going. So number 9. Again, I'm going to start with the secant and replace it with its reciprocal, and I'm going to leave cosine alone. So I'll have cosine theta over 1 over cosine theta. Okay. Now we don't divide fractions, instead we multiply by the reciprocal. So I'm going to have cosine theta from the numerator times the reciprocal of the denominator. So I'm flipping it over to get cosine theta over 1. So now if I multiply straight across, this will be cosine squared theta. And now I have it down to one term. So this is my final answer.